Okay, so now we're going to start doing some applications of the normal distribution. So how can we actually use this? So we have, for this example here, the Bank of Connecticut issues credit cards. Assume that all balances on such credit cards are normally distributed. Okay, so we assume that it's going to take that shape of normal distribution. Okay, then we have the average balance of all customers' credit cards is $845, so that's the mean, with a standard deviation of 270. And then you have two parts. Find the probability that a randomly selected credit card has a balance between $1,000 and $1,440. And then what percentage of the credit cards has a balance above $730. So for the first part, for both parts, what we want to do is we want to take out the information. So first of all, it is normal distribution. Okay, so we're able to use the formulas in this chapter. Okay, the average is your mean, and that's 845. So right here for mean, we're going to write 845. And then we have a standard deviation of $270. Okay, so then what we want to do is we want to find the probability that a randomly selected credit card has a balance between $1,000 and $1,440. So what we want to do is we've got some steps here. Okay, we are trying to find the probability that P is between, or the X is between 1,000 and 1,440. So we want to standardize the score so that we can find the area under the curve between those two numbers. So we want to use the formula for Z, which is X minus the mean over the standard deviation. So our formula to find the Z score. Okay, so we're going to do that for both of these, changing our X value each time. So the first one, our X value is 1,000. Our mean is 845. And our standard deviation is 270. Okay, so we're going to work that formula. Let's see. We're going to do 1,000 minus 845, and then divided by 270. That's going to give us 0.574. Okay, then we're going to do that again for the 1440. So we're just going to change the X to 1440. So 1440 minus 845 over standard deviation 270. 1440 minus 845 divided by 270 is going to give me 2.204. Okay, so now what I'm doing is I'm finding the probability in between the two Z-scores, 0.574 and 2.204. Okay, so from there, we can plot this on the normal distribution curve to see what this is going to look like. So in the middle of our curve, our mean is 0 because we've standardized it. Okay, making the mean 0, the standard deviation 1. So here would be 1 and 2. And I'm going to say that 0.57 is probably right in between 0 and 1, about right here. And then 2.204 is probably like right here. And then what I'm looking for is how much of the curve is this? So what percentage does this fill up? Okay, so we can look this up in our Z table. Okay, so the handout that I just gave you, you can look up these numbers. Or you can put that in your calculator. Let's do both. I don't think I have the Z table handy, so let me grab one. And I just can Google, you can also just, when you're doing your homework, if you don't have that handy, you can Google it. Unless the internet's out, like it is right now. So I'm going to look it up on my Z table. So if I go to 0, so we want to go to the second page with the positive scores. So you want to go to 0.5 and then 7. So 0.5 and then 7, you should get 0.7157 from there. Let me see, I think it's working now. So just so I can show you. Okay, so there's the negative side. And then the positive side, I would go down here to 0.5, so right here, and then over to 7, right here, so 0.7157. I'm going to write that down here. So, okay, and then we want to find 2.204. So go to 2.2, and it's 2.20, so it's just this first column here, so 0.9861 right here. Okay, so if I subtract those two numbers, I can get 0.2704, because remember, we do not want any negative, we're not having any negative percentages. So there you just take that negative, throw it out. So 0.2704 would be that probability. Or in our calculator, okay, you would do normal CDF. Your lower limit would be 0.574. And your upper limit 2.204 for your z-scores. Okay, so in my calculator, second VARS, second one down, normal CDF, lower limit 0.574, comma, upper limit 2.204. And if you have the TI-84, the mean is 0, the standard deviation is 1. And then you get 0.2692. And you see there is a slight difference between these two, but let's look at what that is. You think that's enough to really make a difference? No. Okay, so that's a less than 1% difference. So in your homework, the tolerance, I think, is 0.02 is the tolerance there. So it's just rounding. Okay, here, when I looked up the tables in the z-score, that only goes to 2 decimal places. Here, that only goes 2 decimal places. Here, I did 3 decimal places. So this is actually more accurate, okay, but it's within the tolerance. So you want to look at that. So either one of those would be fine. And if we're doing a multiple choice test, you're not going to have answer choice A be this one and answer choice B be this one. They're going to be at least enough off for you to be able to get within the rounding limit, okay? So there, I'm going to choose the 0.2692 because that's 3 decimal places, so it's a little more accurate. Okay, so that is the answer to A. The probability that a randomly selected credit card is has a balance between 1,000 and 1,440, 0.2692, or 27%, roughly 27%. Okay, then step B, or answer B, is what is the probability, or sorry, what percentage? So now they want you to answer this one as a percentage. What percentage has a balance above 730? So if the average was 845, then you would think that the percentage to have a balance above $730, that's got to be over 50%. So just think about the reasonableness when you do this, when you do your problem. Okay, you want to get an answer that's above 50% for it to make sense. So let's go ahead and do this. So here you're doing the x is greater than 730. So again, you're going to want to standardize that score to get the z-value. So you're going to use the same formula, x minus the mean over the standard deviation. So our X here would be 730. We're still using the mean 845 and the standard deviation 270. So we get that Z value. That's going to give you negative 0.426. Okay, so now you want the probability that the Z value is greater than negative 0.426. So if I graph this in step 2, okay, here's 0, here's maybe negative 1. So negative 0.426 is probably about right here. And we want the probability of it being greater than that. So that's going to be here. Okay, so if you look this up on your Z table, you go up to the negatives. Okay, negative 0.4 would be right here. And then you want the second decimal place, 26 would round up to 3. So here's the 3 column. You want negative 0.43, so 0.3336. Okay, so you get the answer 0.3336, but remember, in the Z table, what they're giving you is the area to the left. Okay, so if I can visualize this, that is this here. So the 0.3336 actually represents this area of the curve. So we want the blue area. So what you're going to want to do is you're just going to want to do 1 minus 0.3336 to get the remaining area on the curve. So 1 minus 0.3336 gives you 0.6664 or 0.667 if you wanted to do 3 decimal places. Okay, or you can put this in your calculator. Now in your calculator, you would do normal CDF. Your lower limit is your leftmost limit. So if I'm going greater than, my lower limit is negative 0.426. And then I'm going to the right, so I'm going this way. Okay, and I'm going to use positive 99 for my upper limit. And again, if you have the 84, the mean would be 0, the standard deviation 1. So second vars, normal CDF, and you have negative 0.426, 99. And then you get 0.665. Okay, then the question asks you, what is the percentage of cards that have a balance greater than $730? So these would both round up to 67%. So here we would say 67% of cards from Bank of Connecticut have a balance greater than $730. Okay, that's what that means in context. Okay, so if you thought about that from a liability standpoint, say there's 1,000 card holders. Okay, at any given time, if 67% of them, okay, have a balance greater than $730, then 67% of this means that at any given time they have about $500,000 in liability on people's credit cards. That's why interest rates on credit cards are so high. Okay. All right, so that's 6.3. Now 6.4, now you're going backwards. Okay. So with this, I want you to really pay attention to the difference here. Okay, here, see where I'm putting my numbers? The z goes on the bottom. What I'm pulling here, this is not a z-score. Okay, this is an area. Okay, so this is the area under the curve. This is a z-score. This just represents something on this little number line that we put on normal distribution. Okay, so now what you're going to do is, given that you have a z-score, or sorry, given an area, find the z-score. So now you're going backwards. So before you were given a z-score and asked to find the area, now you're given an area and asked to find the z-score. So visualize what it's asking you here. We have the area to the left of z is 0.9251, okay, which means this. So 0.9251 to the left of z means that basically 92% of this is colored in. So that's going to be probably like way over here. Okay, so all of this that's 0.9251. That's what they're telling you here. So this is 0.9251. Find the corresponding z-score. So if I look at this graph, it's going to be a positive number. So I've got two options. First option, go to your z-table. You know it's got to be positive. So go look at the positives until you can find 0.9251 in here. Or close to it. There it is. Right in the middle. 1.44. Okay, 0.9251, 1.44. That's the corresponding z-score. Okay, so that's the first option. You can look it up in the table. All right, look up area, find corresponding z-score. Okay, or there is a calculator command for this. So on your handout, that is going to be the 4th page, where it says finding z or x when the probability or the area is given. Okay, so what we're doing is, given the area to the left of z is, and we're going to say, just change this one now to 0.9251. Okay, find the corresponding z-score. So we're given the probability without the context of the problem. So when it's just, here's what the area is, I'm not given the context of the problem, you're going to use the standard normal curve with a mean of 0, standard deviation of 1. So here's what you're going to do. You're going to go second, bars, distribution, and then right underneath normal CDF is inverse norm. So you're going to go select inverse norm, and then you're going to do the area to the left. So if it doesn't give you the area to the left, you have to find it first. This time it is. So put 0.9251. Then your area, or sorry, your mean, which is 0, and your standard deviation, which is 1. And then you're going to hit enter. 1.44. So you should get the same thing, okay, as long as you find it on the table, and that'll give you the corresponding z-score. Okay, so I'm just going to write this down here. Calculator, inverse norm, and then we do 0.9251, 0, 1. All right, so let's look at another example here. I have given the area to the right of z is 0.6736. Find the corresponding z-score. So now they're giving you an area to the right. So if I draw this out, that's greater than 50%, which means to the right, here's 50%. It's a little more than that. So it's maybe like right this much, but to the right. Which means that this part here is 0.6736. okay, which means that this part here is unknown. But in order to find the z-score, we have to find the area to the left. So to find the area to the left, I have to subtract from 1. So I'm going to do 1 minus 0.6736 to give me that part. So 0.3264. So the area to the left of this z-score is 0.3264. That's what I want to find either on my chart or in my calculator. So if I'm putting this in my calculator, I'm going inverse norm. Okay, area to the left, 0.3264, 0, 1. I don't know why the black, there it goes. Oh, it keeps flashing in and out, that's weird. Okay, so second distribution, inverse norm, 0.3264. Again, I'm doing that because I want the area to the left after it's given me the area to the right. And then 0, 1. That's going to give me a z-score of negative 0.4498. That's going to round up to 0.45. So negative 0.45. And I have all of these curves here on here for you guys because I think it's important for you to draw it out to visualize it, because you could easily pick a positive 0.45, but if you see here that this is to the left of the mean, then you're going to know, okay, that has to be negative. So it helps you to be aware of those things because you guys know how to read a number line. Okay, let's look at some examples. So the area from 0 to z is 0.1965 and z is positive. So again, visualize what this is going to look like. I didn't draw or put these in here for you, but you can just go ahead and draw one. Here's 0. And the area from 0 to z is 0.1965 and z is positive, which means it's on the right. So here's my z. And this area here is 0.1965. Okay, so I want to find the z-score for that. So I want the whole area to the left of this, which means I'm going to want all of this. Okay, so I can take this area here and this area here and add it. What is the area to the left of 0? 1/2, 0.5. So half of the curve is to the left of 0, half of the curve is to the right of 0. Okay, so if half of the curve to the left of 0 is 0.5, I'm going to go 0.5 plus 0.1965. That's going to give me the total area to the left. So 0.6965. Okay, that is the total area to the left of z. Then to find z, then I'm going to go inverse norm. My total area to the left, 0.6965, 0, 1. So second distribution, inverse norm, 0.6965, 0, 1. So 0.514, 0.514. Okay, and then you can check that on the z table. So look up the z value 0.51. It should be close to that, but it's probably not going to be exact, okay, because it's rounded 3 decimal places there. So 0.5, where's the mouse? There it is. Lost it again. There it is. For some reason, it doesn't like to show up on this page. That's weird. All right, so 0.51 gives us 0.6950, and then 0.526985. So is it reasonable to say that 0.6965 is in between those two numbers? Yeah, and if I can't, the mouse isn't showing up on here, so yeah, it's up there though. I'll point it with my finger, but I can't reach that high. So it is in between those two values right there. Okay, so then we have another one similar, except this time z is negative. Okay, so here you're going to have the area between 0 and z, so here's 0, and z is negative, so z is over on this side, and that area is 0.2720. So here's 0.2720. Okay, this side is 0.5 over here, which means the rest of this would make up the 0.5. So you have two options. You can add the 0.2720 to 0.5, then subtract from 1 to get this remaining area here in red. I'll color in just a sec. This is what we want. We need this area in red to find the z. Okay, or I know that from this side to here is 0.5. So I can just subtract the 0.5 minus 0.2720. That should give me the remaining area in red. So 0.5 minus 0.2720, 0.228. So this should be 0.228 right here. Okay, let me just check that. 0.228 plus 0.2720, 0.5. Okay, so that should be good. This total area here is 0.5, which brings us to the 0 right here. So I have the area to the left is 0.228. That'll give me the z-score. So I'm going to go inverse norm. And then I don't know why I drew the equal sign. Then we have 0.228, 0, and 1. So second distribution, inverse norm, 0.228, mean is 0, standard deviation 1, point negative 0.745. And that'll be this z-score right here. And then you can also check that. Okay, look up negative 0.745 in the chart. Now the mouse is showing up. There we go. So negative 0.7, 0, 1, 2, 3, 4, 5. So it's in between here, 0.2296 and 0.2266. What was it? 0.228? That's between those two numbers. So we should be good there. Okay, and then we have the area in the right tail is 0.2050. So what does that look like? Let's see. Let's draw it out. So in the right, that's over here. So about 20%. This is a little skewed. Sorry, I can't draw. Okay, but this area right here is 0.2050. How do we get the remaining area? This much? It's all of it. Wouldn't it just be this area plus this area would equal 1? So if I subtract from 1, I can get that area. So 1 minus 0.2050, 2050. So 0.795. So the area in the left of the curve is 0.795. So now to get the z-score, this guy right here, we're going to go inverse norm, (0.795), 0, and 1. So second distribution, inverse norm, 0.795, 0, and 1. So 0.824. All right, so that's our z-value, 0.824. Okay, then just a little bit more, 6.4. Now we're going to do applications. All right, so to find a data value of x when a probability is given. So if I take the z formula and I solve it for x, let's see here. I am going to get x by itself, so a little bit algebra here. I'm going to want to multiply by the standard deviation on both sides. So I'd have z times the standard deviation. These would cancel. Then x minus the mean. And then I'd want to add the mean to both sides. So then that should give me z times the standard deviation plus the mean equals my x value, because then those would cancel. Okay, so I didn't really write it linear. Hold on. Let me leave a little more room here. Okay, so we multiply by the standard deviation on both sides. There we go. So standard deviation times z, or I'm going to do c times the standard deviation, equals x minus the mean. Then you're going to take the mean and add it, and then they cancel out. So that's where we get this here. Z times the standard deviation plus the mean. Okay, so in that context, let's do this problem here. So let x equal SAT scores of students. Assume that it's normally distributed with a mean of 1,020 or 1020 and a standard deviation of 153. Find the SAT score such that the area under the curve to the right of x is 0.10. So before you do step 1, okay, let's go ahead and draw this out. So find the x value, so the actual score. So the area under the curve to the right is 0.10, which means this. If this area right here is 0.10, this area right here is 0.90. So what are they asking you? Find the score that corresponds to the top 10%. Okay, now of course they're not going to ask it that way because that would be too easy, right? We're going to make it more complicated. Okay, but that's what it is. So 0.10 is to the right, that's the top 10%. What is this score? So first, to find the score, we want to find the z-value. So to find the z-value, okay, find the corresponding z-value here. So inverse norm, area to the left. Area to the left is the 0.90. So 0.90, 0, and 1. So inverse norm, 0.90, 0, and 1. That gives us a z-score of 1.28. Okay, so you get your z-score, then use this formula to find the x value. So the formula is z times the standard deviation plus the mean equals your x value. So if my z-score is 1.28 times my standard deviation, which was given as 153, and then I add 1020, what is that x value going to be? So 1.28 times 153 plus 1020 gives me 1215.84. We can round up to 1216. So the corresponding SAT score, okay, such that the area to the right of the curve is 0.10, is 1216. Or the top 10% of scores is 1216 or above. So if you get a 1216 or above on your SATs, you've scored in the top, well, it's actually the top 90th percentile, or the top 10% of people testing. All right. And then you have just some more examples, just now without a context, but we could just say that maybe this is, maybe it's like the math section of the SAT, 550 for a mean and 75 for standard deviation. I might be being a little hopeful with that, but let's just say, okay. Find the corresponding value so that the area to the left is 0.0250. Okay, so for this one, we would go, same thing, so draw this out. They're giving you the area to the left, 0.0250, so you don't need to do any subtraction there. They're already giving you area to the left. Find the corresponding z-score. So go inverse norm, area to the left, 0 and 1. So let's see. Negative 1.96. And then plug that into our formula with z times the standard deviation plus the mean. So in this case, the z is negative 1.96 times the standard deviation of 75 plus our mean of 550. So let's see here, negative 1.96 times 75 plus 550. So 403. But there is another calculator shortcut. The very last example on your handout. Okay, this is what this is telling you. So if I did this problem and instead of using 0 and 1 for my mean and standard deviation, I use the actual mean and standard deviation, if I remember correctly, it should give you those values. So second distribution, inverse norm, always do the area to the left. Okay, then put your actual mean in, 550, and your standard deviation of 75. There you go. So it just skips that last step right here for you if you are actually given a mean and standard deviation. So like, for example, example B, okay, you have the area to the right is 0.9345. So you still have to find the area to the left. So right is this way, 0.9345. Okay, I need to find this little missing piece right here. So area to the left is going to be 1 minus 0.9345. So 0.0655. So this z-score, we can go ahead and find the z-score, or we can just go ahead and plug it in for the problem. So I would go here, inverse norm, .0655, with my mean being 550 and my standard deviation 75. So second distribution, inverse norm, 0.0655, 550, 75. So there, that should give you a corresponding score of 437. Okay, then C and D. And then I think there's some practice, just a little practice. Okay, so for C and D, we have the area between mean and x is 0.4700, and x is less than the mean. So what is this saying? All right, so my mean is in the middle. X is less than the mean, so maybe it's like right here. And the area between it is 0.4700. So all of this is 0.4700, which means I want, in order to find x, I need this little red part right here. So I know that this is 0.5 from the mean to x. So if I just do 0.5 minus 0.4700, that's going to give me that little remaining part right there. So that's 0.03. Okay, so I'm looking for the corresponding value 0.03. So that's your area to the left. And then we're still in the context of this problem. So inverse norm, area to the left, 0.03, mean is 550, standard deviation 75. So inverse norm, 0.03, comma, 550, comma, 75. So 409. Okay, and think about the context too as you're doing this. So I put this in the context of the math SAT. So what this is saying, okay, so for the score 409, that is way down here. Okay, which means that this is only higher than 3% of scores. So it's the bottom 3% or the third percentile, which means 97% of people would score higher than a 409. So always put that into context because it helps to understand why you're doing all of this in the problem. And then the area between the mean and x is 0.41, and x is greater than the mean. So this is very similar, it's just the opposite side here. So here is your mean. X is greater, so we'll say it's right here. And then this area is 0.41, and this area is 0.5. So to find the total area to the left, you can just add those together. So that would be 0.91. So all of this here is 0.91. So then I would go inverse norm, and then 0.91 is the area to the left, mean is 550, standard deviation 75. So inverse norm, 0.91, comma, 550, comma, 75. So 651. Okay, what does that mean? That's the score right here. That's the 91st percentile, or scored higher than 91% of people taking the test, or top 9%, if you looked at it from that context, 651. Okay, so just one practice problem here. Again, with SAT scores, they are normally distributed, so it's in context of what many of you are facing. So it is really good example problem. Sorry if it's a little overdone. So take us about 5 minutes to work on that, and then we'll go over those. And then I'm going to start the vocab for chapter 7 after that. Okay, it's been about 5 minutes, so. All right, so the NCAA requires Division I athletes to score at least an 820 on their combined math and verbal parts of the SAT in order to compete in their first college year. Higher scores are required with poor high school grades. So I think that is with the minimum 2.3 GPA for the NCAA, and this might be outdated. So it might be higher than that now, but I'm not quite sure. Is anybody trying to go Division I here? Yeah, volleyball, right? Yeah. So I think you'll be okay with 820 though. That's on both. So there's like a 410 on both sections. But there are some students who struggle with this. So there are these minimum requirements here. In 1999, so this is pretty outdated data here, the scores of more than 1 million students taking the SATs were approximately normal. So your mean was 1017, standard deviations 209. So I know that the mean has gone up significantly since then. So the SATs have gotten harder, but students have actually gotten smarter and gotten better at taking the test. But anyway, so what percent of all students had scores less than an 820? So this is in the context, and we are given a score, not a percentage-wise. Okay, so this is going back to the first part of this chapter. So if we take a look here at our normal curve, the mean score is 1017. 820, over here somewhere, we know it's below it, okay? We want the percentage. So remember, the percentage is this right here. So we want the area under the curve. So to find the area under the curve, we find the z-score. Okay, so the first thing that we're going to do for this problem is we're going to find the z-score. Okay, which means we're going to do z equals x minus the mean over the standard deviation. Okay, so they want the percent, you find the z-score. If they give the percent, okay, they're giving you the area under the curve, that's the inverse norm. So that's the difference there. If they're asking for the percent, it's normal CDF. If they're giving you the percent, then it's inverse norm. And that's why it helps to draw it out. Okay, are they giving you on the bottom of the curve, like they did here, or are they giving you inside of it? Okay, so here you're going to get your z-score. Your x is 820. Your mean is 1017. And the standard deviation, 209. So let's see. 820 minus 1017 divided by 209. So negative 0.943. Okay, so that is this corresponding z-score, which all that means is I've taken these scores and I've standardized them, right? This is 0 now, and then this is negative 0.943. So I've just converted them into the standard normal curve. Now I can look up what this percentage exactly is. So then I can either do, look up negative 0.943 on my chart. Let's do that, let's do both. So my negative 0.94, 0, 1, 2, 3, 4, right here. and 3. So it's going to be in between these two numbers. So between 0.1762 and 0.1736. So let's look that up exactly in our calculator. So we're going to go, you're looking to the left. So normal CDF, your lower limit to the left goes to negative 99, all the way to the left, and then negative 0.943. So 0.173, right in between those two numbers. Okay, so we get 0.173 after we do that, so normal CDF. So that's what this is right here. And let me just write this down. Step 2, normal CDF, negative 99, negative 0.943. And that's because I'm looking for the area to the left. So if I'm going to the left, I go to negative. If I'm going to the right, I go to positive. Okay, so I get that answer, 0.173. Now let's actually answer this question. So the question is, what percent of all students had scores? So roughly 17% of students scored less than 820. It's actually less than or equal to 820, but that's just semantics there. So 17% scored less than or equal to 820. So it's a lot more than you would think. 17%, that's a pretty significant amount, I would think. All right, and then A part 2 or B, just because of typo there. Anyway, there we go. Okay, the NCAA considers a student a partial qualifier or eligible to practice and receive an athletic scholarship, but not to compete, so basically redshirt. Okay, if the combined SAT score is at least a 720. So use the information in the previous exercise to find the percent of all SAT scores less than 720. So you're doing the same thing, the X just changes to 720. Okay, so you don't even really need to draw it out. You just change that X from 820 to 720. So 720 minus 1017 over 209. So let's see here, 720 minus 1017 over 209, we get negative 1.421. And then I would do normal CDF. Going again, area to the left, negative 99, negative 1.421. So normal CDF, negative 99, negative 1.421, 0.078. So then that's roughly 7.8% or roughly 8%. We'll say roughly 8% of students scored less than a 720. Okay, so that answers both of those questions in context. All right, so after this, I did make a quiz practice for you guys. We're not doing this part in class. I just want to show you it is on Blackboard. If you go to Chapter 6-7 test, Chapter 6 quiz review answers. There's a PDF there with the answers, just to help you out with your quiz. Do the practice first, then look up the answers, see how you did. Then there's, do some additional practice or correct yourself, change the numbers around, work with it. If you want some additional practice, again, come to office hours and I can go over those with you.